Welcome to Dave's Workshop and Garden Railway. Please share this video to spread the joy of live steam. Don't forget to like and subscribe for more videos. These are the photos showing how I built the Quarry Hunslet locomotive. I based the loco on Dave Watkins's excellent Wild Rose 3 locomotive plans. Link in description. Scaling the dimensions up to 1 inch or 1/12 scale. My new scale. It is very easy to do. Just divide the metric dimension on the plans by 16, and that is the new dimension in imperial. I like both systems. The wheelbase was increased to 4 foot to make it more large quarry size. After building the large 24 mm to the foot de Winton, and being so pleased with its slow-running performance, I wanted to build another large oscillating cylinders loco, but a conventional loco, and one with a coal-fired boiler. Let's get into it. Here are the sawn billets for the wheels, 60 mm diameter free-cutting mild steel. I borrowed the bandsaw at work. The wheel blanks are chucked, faced, recessed, then drilled and reamed for the axles, in one setting. My trusty round-nosed tool is very useful. The wheel recesses are then painted with ordinary domestic enamel paint. The wheels are now mounted in the true running mandrel, for tread and flange turning. I ground a form tool for the 10-degree flange angle and root radius. The lathe compound slide is set over to generate the 3-degree tread taper. This helps the loco track nicely on the rails. The finished wheels. Here's my setup for sawing the frame side pieces. 1.6 mm steel sheet. Long cuts are not easy with a hacksaw. I hadn't got my Eclipse No. 55 sheet metal saw yet. Here's the side pieces clamped together for finishing. Milling the axle bush slots in the frames using the lathe's vertical slide. This loco does not have springing. Solid is fine for the garden railway. The characteristic circular-ended cutouts in the frames, with the buffer beam spacer blocks behind the frames. Frames with buffer beams attached, all 1.6 mm steel. Wheels, axles, and axle bushes fitted, to see how it looks. On the shelf with axle bush retaining bars, to keep the wheel sets from falling out, checking for buffer height against the LGB stock. Checking for clearance in the railway's return loop cutting. The aluminium tubing is to keep the wheels apart. They have not been glued onto the axles yet. That paver needed moving. 5BA screw, being converted to an 8BA thread for retaining the coupling rods on the crank pins. Cranks, and coupling rods fitted. Out on the garden railway. Cutting and marking out the smokebox end plates from 1.6 mm mild steel. I needed to make the smokebox before making the boiler. I use bronze LG2 plain bearings for all my oscillating cylinders. They have a good finish, and parallel bore. Brass disc blank for making the semi-circular angle pieces for the smokebox ends. Using 1.2 mm brass sheet. In the mandrel for turning the outside diameter. Disc bored right out to give a 1/4 inch section. Thin strip outer edge silver brazed into one strong piece. Hole sawing a large hole in one of the firebox end pieces. The 2 bored pieces. The larger hole is for the boiler. 1.6 mm steel smokebox wrapper applied. Now you can see the semi-circular angle attachment piece, along with conventional 1/4 inch brass angle. The angles are flush riveted onto the smokebox front end plate. Smokebox on the loco to see how it looks. The start of the boiler attachment bracket. On the mandrel ready for turning. Disc with outside diameter turned, lined up with the correct side of the smokebox. Finished disc with strip, and boiler shell piece for forming the strip circular. Nearly ready for silver brazing. The finished item. I took a light skim out of the bore in the lathe so the boiler barrel would fit. Now the boiler can be fitted to the smokebox, with a good seal. The chimney base, contoured in the lathe, and the base milled in the lathe to fit the smokebox wrapper radius. The lovely blue chimney base. That's the color required to break the Loctite bond with the mandrel. Turning the smokebox door. It was soft soldered onto a mandrel. Trying to get the smokebox door profile just right. Turning complete. Making a start on the hinging. The door is hinged and swinging. I am a big fan of using roundhead screws to simulate rivets. Making a start on shaping the bronze chimney cap. On the mandrel. Marked out, ready to cut. The first radius was filed. The large radius was formed with the steam diesel worm wheel form tool. The cap has been filed smooth. The cap has been polished. I really enjoyed the result. The finished cap, slightly discolored after removing from mandrel. I made the chimney as tall as for the cabbed version of the Loco. But I'm not building a cab. I like open cabs, good for accessing the controls. Handles installed. I used M3 thread for door locking. Drawbar and brackets. Out on the line in all his beauty. Smoke up the chimney at last. Boring the cylinder port face to accept the cylinder. It is soft soldered to the angle plate. Boring complete. Next one ready to mount. Cylinders and port faces. Cylinder end cover. I screw-threaded the cylinder and end cover. As I maximized the bore diameter, there wasn't the wall section for screws. This is how I saved material in the making of the lower cylinder end covers. The piece on the right was a whoopsie. At red heat brass is like plasticine. I was tapping it to move it a little. Cylinder components just about finished. Making the end cover O-ring retaining plate. O-ring and retaining plates. Starting on the boiler. Making the backhead flanging former from 4mm steel. Removing a little, as it was too long. Backhead with former. Firebox tube plate before forming with former. Progress, so far. Experimenting with the firehole size, I went with the smaller one. I wanted a water on all sides of the firebox, traditional type boiler, not a dry backhead or even worse dry sides too, wink. Firebox riveted together, fusible plug bush at the top, making stays not required. The lower tang is to hold the grate and ashpan. This is a 3-tube boiler with 1/2-inch domestic plumbing pipe flues. Tube plate holds the flues in position for brazing. The front of the firebox has been brazed so far. Rear of firebox and tubes brazed in. Lots of silver braze was used to allow for remelting of subsequent heatings. The front tube plate is not brazed yet. It would not fit into the boiler shell. Testing the boiler parts in position. Inner and outer have not been joined yet. The 2-inch ID boiler shell has been brazed to the firebox outer. The backhead, made from 1.5mm copper, with bought-in water gauge, and blower valve. Large bronze regulator bush in position. I needed to cut out a large hole in the 1.5 mm copper firebox outer for the steam collection dome. The copper is very soft. This was fraught with disaster. Fearing a dig-in and buckling at any time. But this did the trick, drilled holes along the periphery, no dig-in occurred. Success. Line scribed for filing too. Mounted in the wood vise for filing, the backhead isn't fitted yet. The fully brazed firebox. The backhead has the bushes brazed in. The pipe is for the blower to get steam from the dome. Fitting the inner and outer boiler parts together. Steam dome brazed in. It is made from a discarded piece of cylinder material, screw-threaded on the end. The firehole ring holds it all together. Oversize boiler feed bushes, so stays aren't required on the flat sections. Building up the foundation ring or mud ring from pieces of copper. Brazing complete. The tube plate has been brazed too. You can see the regulator bush or wet header at the top of the tube plate. Holes plugged, except for steam dome for some leak testing. You can see the blower pipe in the steam dome. This is my daytime brazing setup in the garage, with curtain to keep the light out. The bucket of citric acid solution, for removing flux deposits. The finished boiler, all pretty in pink. This is a boilermaker's favorite color. Using lung power to find the leak at the regulator backhead bush. This was the first test under pressure. I had to use the camera as I couldn't blow and look at the bush at the same time. The boiler full of water in the fridge. Cold water occupies a lesser volume than hot. Leak testing the boiler over a mirror with gentle heat.
Here we are, pressure testing the boiler using nothing but heat. There's a pressure gauge sitting on 0. I've got the boiler completely full of water without any air gaps. Just filled it through here. These are screw-in plugs. I've got all the places plugged. I've got a regulator bush there plugged off. I got this pressure gauge connected to my blower bush. Bushed at the front as well. Got my brand new Cyclone burner. Let's heat up this boiler a bit. It's got a nice warm temperature. I've just heated it previously. Get this burner out this vise. There we go. Play the flame on the barrel. Okay. Lovely colours. Watch this. Watch this gauge go up. Got 10 pounds square inch. Take the burner off, keeps on climbing. Nearly 30. This boiler should have a working pressure of about 40 pounds. That's 30 pounds. Really zips up there. taking it to £40. Whoa. So about 45. Just to show this boiler isn't very hot to the touch. There you go. Nice temperature, 40 or 50 degrees. Sorry about the lighting. I'm in the garage. It's down to 4, just over 40. Here's the burner. You can see it runs red heat on the tip, hey? I've been doing a lot of brazing with this recently, and it's very effective indeed. And maybe converted to the cyclone burners. There we are, sitting on 40. That's it, folks. No pumping required, just using heat and expansion of water. There's no steam in there, it's all quite just nice and warm. £40.
Baking the painted firebox end, too smelly for in the garage. Engine block paint creates a strong, durable finish. Black paint, like thick steam oil, covers a multitude of sins. Out on the line testing the aesthetics. Pressure testing the boiler. My faithful 0 to 86 psi pressure gauge screwed into the blower bush.
Listen to the lovely cooling down contractions. I've just been heating this with the gas torch to 40 psi. Using a safety valve from one of my De Wintons.
Water gauge fitted. The regulator blanking bush will be the regulator eventually. Drilling the steam escape holes in the safety valve end cap.
Testing the new safety valve. It's supposed to lift at 40.
Drilling the whistle valve body. Manual turning excess off upper whistle valve body. The safety valve and whistle valve complete. Extra steam takeoff in lower whistle valve body. Whistle valve component parts. The 0 to 80 pressure gauge mounted with lots of turns of brass tube. The former for forming the pressure gauge tube. I Loctited the pressure gauge nipple to the 1/16 inch tube. The base for the smokebox. The fixing tangs for securing the smokebox to the frames. Brass angle riveted to smokebox, to screw the base to. Sizing up bought-in boiler feed check valves, clack valves. Working out how to position the blower pipe. A peek at the regulator output manifold. Milling a port block for the cylinder to rock against. Cylinders and port blocks. One cylinder has a cover. Ports drilled. The larger hole is for the exhaust, for forwards running. Smokebox with integral reversing valve. The piping is sized to be optimal when driving forwards. The setup for milling the rotary reversing valve's banana slots. The slots are finished. Now the port face needs polishing flat and smooth. 1/8-inch steam pipe brazed to the regulator manifold. Reversing block setup, with steam and exhaust pipes. Cylinders soldered to port faces. Ports drilled, and chamfered to open up the timing admission. Port blocks and cylinders, mounted to frames. A package arrived in the mail from my friend at toolsnz.com. A 100 ml of each. I didn't know which I'd use for the pistons. I chose aluminium, this is one long piston, to take side load. A 2, silicone O-ring piston. Boiling up a piston to measure how much clearance to allow for expansion. Piston rod big end pieces before brazing. Brazed and ready to fit to the 3/16-inch stainless steel piston rods. There's the piston rod, threaded on the end, so the big end can be removed. A coupling rod block is required to raise the cylinder to horizontal. The block has been fitted. Using a BS1 center drill as a pin. Checking on the piston overlap of the port. This end cover will be Loctited. The rear side port overlap. There's not enough port showing. That looks good. Rear cylinder end cover drilled and chamfered ready for hex key broaching. Sharp-ended hex key being pressed into the hole. Finished 4 mm AF hex. I need to be able to remove these end covers. The cylinder assembly is ready to go. That end cover needs Loctiting into the cylinder now. The piston can pass right through the buffer beam.
This is very pleasing. This little double action pump is powering the cylinders along nicely. Look at that lovely slow running. This is the beauty of large scale.
The smokebox is empty. The new big bucket, dead leg lubricator, with the finished reversing valve assembly. The manifold is fixed to the boiler with screws. The nipple for the silicone tube connection of the lubricator. O-rings ready for the reversing valve connections. Here is the regulator bush blanking piece. It is actually the partially complete regulator body. The long regulator steam tube needed to be thick wall, so I built it up from 3 pieces of K&S brass tubing brazed at the ends, using a piece of wire to line up the backhead and front tube plate holes. The long regulator tube screws in, acting like a longitudinal stay. Screws hold it in position, sealed with silicone. Here is the whole length of the regulator assembly. Firebox end threaded. This is the end that the taper screw-down valve seals against. Regulator steam pipe taking steam from the top of the dome. Building up the regulator spindle from stainless steel. A coarse taper as the thread is quite fine-pitched. The completed regulator assembly. Filing the long regulator handle. The tool for unscrewing the regulator from the boiler. Out on the line for the aesthetics. The long regulator handle. I designed the boiler to my own specs, no magic formulae required. Firehole opening just large enough for a teaspoon. Making a start on the smokebox blower elbow. It was shaped by filing. I am still very pleased with this component. The blower pipe is getting there. It has to fit in with the saddle tank, that I have not made yet. The pipe fittings. The nipple will be Loctited onto the 3/32 inch brass tube. The blower piping is complete. Crosshead style water pump body, to be driven by each cylinder. 1/16 inch brass stop bar, to prevent the valve sealing against water inlet. The complete pump, there will be 2 of them, 1/8 inch bore. The fusible plug body. I wanted all the bells and whistles on this loco. Filled with 6337 solder, melting at 183 degrees C. I often joke in my videos, better not expose the crown sheet. Blast nozzle fitted. The lubricator is soldered to the stretcher. We get a bit of steam drying from the lower flue. Assembly time. One can see the ring of solder around the lubricator body finally Loctiting the wheels to the axle. There will be no eccentrics after all. Close-up of the axle bush keeper in position. These allow the wheel sets to be easily dropped from the loco, if need be. There are spaces fitted between the wheels and axle bushes. The wheel spaces have been oil blackened. The newly blackened coupling rod, riser block. All plumbed in, ready for the first run on steam. The steam and exhaust connections screw out from the reversing block, and seal to the O-rings in the port block. The small cyclone burner, providing the heat.
Stop. It's my impromptu drain cocks making that gurgling sound.
The lubricator, prior to syringing out the water. The marked-out footplate, ready for cutting out, from 1.6 mm steel sheet. Another mammoth task for the hacksaw. Footplate, cut out, ready for filing. Interior, cut out to suit firebox and smokebox. The footplate fitted, the boiler is lowered on after the footplate. 8 1/4 inch brackets for fixing the footplate to the chassis. The bracket drilling setup. The drill is barely long enough. 4 brackets fitted so far. One can see the brass screw in steam dome cover. The cutout in the footplate for the lubricator cover. The silicone tube is sufficient for the lubricator. Outlining for the middle brackets. Middle bracket location, for where dummy springs should go. All 8 brackets in position on the frames. A tool for clamping onto piston rod, without damage, to remove big end bearing. After running the loco on steam, I realized that the loco needed cylinder drain cocks. Carefully marked, so that I only drill the holes in the bottom of the cylinder. Cylinder drain holes drilled. Stainless steel cock bodies, with rotating shaft with 1 mm cross drillings. Baking the enamel, on the cylinder cover, 120 degrees Celsius for at least an hour. Fully dressed cylinder. Another drain cock, almost finished. Here's the Eclipse 55 sheet metal saw, sawing another cylinder cover from 0.6 mm steel sheet. Holes drilled for drain cocks. Both cylinder covers on, and painted. Piston at end of stroke. Same for the front side. Shame about the paint finish. How I built the Crosshead pumps.
Pump barrel from 1/4 inch brass rod. Threaded 1/4 inch and drilled ready for reaming. Tapped 5 30-seconds for the end plug. Valve housing cross-drilled for barrel and stop pin. Finished bored and tapped. Ready for silver brazing. All brazed up. Unfortunately, the stop pin hole is full of braze. Drilled hole out again and pinned it. Stop pin in position. End plug threaded and chamfered. Testing that the end plug fits the pump. Rear of end plug drilled to tap 8BA. Gland nut drilled, bored and chamfered. Tapped 1/4. Handy mandrel for chamfering. Bottom fitting, water inlet, threaded and chamfered. Board for water passage. Position finding for the water inlet hole. Drilled and counterbored for 5 30-second tube. Tube Loctited in position. Ball, O-ring and bottom fitting. Pump finished with a borrowed pump ram.
Handed brackets for holding the pump barrels. The bracket keeps it in position. An 8BA screw on the end keeps the pump from being pulled off the buffer beam. All ready for the driving rod. Design work, and technical drawing. O-ring valve seat used on both sides of the pump. It's been very successful in use. Right-hand side frame completely removed. 1/16" brass rod is stiff enough to do the job. The saddle tank. Every proper loco needs a working water tank. Wink. 0.9 mm copper sheet for the inner and outer shells, 1.2 mm brass sheet for the profiled end plates. The parts were brazed together for strength and caulked with soft solder for water tightness. Before trying to hole saw the large filler hole, I brazed the copper firehole tube bush on for rigidity. The hole sawing was stress-free. The copper is quite rigid in this application. The bypass valve is mounted straight on top of the pump outlet. Testing that the tank is watertight. A glimpse of the end plate and inner. The water bypass telltale pipes on either side of the filler opening. Bypass back to tank pipe on lower left of tank. Truing up square brass section for pump delivery side. Pump with delivery pipe, going towards the boiler clack valve. The convoluted, water delivery pipe and connector. Pump delivery side finalized. It's not pretty, but it's well hidden by the footplate. Insulation on top of boiler. Water feed pipe visible at bottom left of tank. There's a balance pipe behind it too. Smokebox with blower finished. A tiny nozzle, 0.3 mm is best. Borrowed from a De Winton, Goodall valve, stacked on top of the modified clack valve. I bought in some Bowden cable, for the reversing valve actuation. A new blower pipe, that will fit with the saddle tank. The completed left-hand side coal bunker bodywork, made from 0.6 mm steel. The right-hand side being made. Wrapped around a 1/4 inch rod, that is threaded for attachment to the footplate. Both sides complete, the top surface, and rod are soldered on. Mild steel solders beautifully with my 80-watt iron. Fitted in place. Minimal bodywork is such a joy, there will be no back sheet. Pumps ready to be plumbed in. Making a start on the reverse stand. There is a lot of filing to do. Stand and lever, part finished. Filing the attractive waist. Stand in position, it's so big due to the amount of throw needed. That's a lot of travel, to get the required throw at the required height. Lever being Loctited, with distinctive 3/16" ball that links to the live diesel. Just fits above the clack valve. Plan view. That big regulator handle is due for the chop. The reverser is held on to the footplate by brass angle. That fire hole needs a door. Hole drilled for cable, we now need the tube. This Bowden cable solders quite nicely, but needs cutting to the right length. Brass reverser tube, cut and bent to size. Slot filed for cable to be soldered to. All done, and fixed with tube clamping bracket. Every engine should have a whistle. So, let's make a start. The circular steam groove in the endpiece. Racking, the steam outlet, for steam to pass over the whistle opening. The opening is complete. The whistle components. Testing the whistle with the mini pump. It's not good. More later. ... It is time for the great time. Cutting a piece of my 4mm, hot-rolled mild steel. Cut and trimmed. It's a small grate, but a lovely deep fire. Deburred, and ready for drilling the rosebud holes. Center drilled holes, one complete row, then turn the piece around, and drill the second row at the same height setting. Holes drilled through, in the bench drill. The completed grate in position. It fits quite well to the boiler, but needs its ashpan to keep it in place. Milling the ashpan sides to the correct dimension for the grate. Here's the ashpan holding the grate in position. Conical grate holes on the underside. No rear ashpan support yet. Making the slot in butane burner. The holes were spotted from the grate. That's the burner tube with the air holes drilling jig, a commercial gas jet, and the jet holder. Gas burner in position. Silicone tubing used for the gas line. Briefly testing the burner with no water in the boiler.
Very exciting time, lads. Got a gas burner in place in the grate. Can't run it for long because the boiler's dry.
Rapid fire, gas burner development. Gas burner in position, but not yet secured. Grate and ash pan. Here's all my specifications, so that I can make more if required. The final exterior iteration of the burner. Running a bit rich. The burner top plate is 1.2 mm, and the rest of the body is 0.5 mm brass sheet. Burner tube brazed in, no more opportunity for adjustment. Ready for another test run. Nice flame color, but the top row don't seem lit. A peak of blue. This is what I use to light the gas burner. Without draft there's a big backfire. The regulator handle is being cut down to size. The firehole door is made from 1.6 mm steel, brazed to a hinge rod, supported by bearings mounted to the footplate. Experimenting with a disc magnet to keep the door snapped shut. Oil blacking the new door counterbalance weight. Balance weight, and top air adjustment dial fitted. The door is remotely fixed, so that there aren't any more holes in the boiler. The counterbalance weight works well. The blacking helps hide it and protects it from rust.
Here we are, the firebox door. We've got a counterweight here holding it closed, hopefully, and just snaps closed. I got this air adjustment dial here for the top air. I think we're going to need some for the gas.
Ready for fixing the whistle. A hodgepodge of screws to hold the port block onto the frame. Removing some height from the lubricator so that the lid is flush with the footplate. The whistle, snug between the frames. The lubricator cap sitting nice and flush now. The gas burner secured by a gas line clamp. An unsuccessful steam test for the whistle. The gas burner requires draft.
My new whistle doesn't work under steam, so I'm going to compare it with the large De Winton's whistle, which is excellent. This is the bad whistle, just blown by my mouth. This is the good whistle. What a difference.
A close-up of the whistle opening on the large De Winton. Whistle end set up on the solder mandrel for some remedial machining. Whistle disassembled. Steam groove opened up, bored out for more volume. Having a good clean in the ultrasonic bath.
Success! Action shot.
Goodall valve built up from hex stock brazed to round rod. The finished item. Such a great invention. It just needs a short piece of silicone tube slipping on. New valve fitted on top of the boiler feed valve. Plenty of white sealant to keep it from leaking. I made these rolling road rollers so that I could test run my locos better. Wheels dangling down with no load on them isn't the best. These are rather low, so I chopped them up with wood blocks. Let's get finishing off the loco. Loco frames, ready for spraying and baking. The new 8BA round head screws bought in for finishing the loco. Let's blacken them to hide them. Heat them up and dip them in the clean engine oil. Here's some I prepared earlier. It's a great finish, much better than painting them. Reassembly time. Painting the wheel sets. Baking the wheel sets and coupling rods in a low oven. Assembling the reversing valve connections. The whole underside is done. I painted the back of the wheels and axles to prevent rusting. The cranks and coupling rods are painted with domestic enamel paint. Likewise with the water pumps and their piping. The frames are painted with spray on engine block enamel. The lubricator is piped in with silicone tube. This is sufficient. The steam and exhaust connections have been soft soldered.
This loco is such a joy. I've got the burner ring turned up. I've got a slightly bigger jet in the burner. I've got a warm water bath for the gas tanks. You've got some good pressure in. Even blew this gas line apart. And now we're individually testing the pumps. I'm testing the right-hand pump. If I open the bypass valve, water dribbling through. Closed again. And it loads up the motor. This loco is partially painted. I started it with the drain cocks open, it was lovely. And closed them while it was sitting. And closed them while it was running. Look. Got a bit of water in the boiler now. Sight glass is right up. Yep. Whistle sounds great. Safety is feathering. All is good. Running on the rolling road finally. All the steam leaks seem to be sealed.
The chimney has been oil blacked too. I love that process. Certain things will be left in the natural brass color. It is time to finish off the saddle tank. The saddle tank needs a filler cap. Here it is on the tank. Featuring a soldered-on 3/16" bronze ball, for handling. Rapid fire. How I made the dumb buffers from Quila timber. It's as hard as nails. As this was a small Quarry Hunslet converted to large, it needed a dome. Here I am machining the dome, the hard way, by manual CNCing. Here's the steel test strip for the Smokebox paint, to see if it could cope with high temperature. I used domestic enamel paint. Test in the paint oven at 180 degrees C. You can see the temper color on the steel. The paint was fine afterwards.
Lovely steam test. The pumps are pumping nicely to bypass. We're officially baking the enamel on the Smokebox. Any excuse for a run? Good old top-up valve. Plenty of water. Some safety valves just fizzing a bit.
The very first run on the line. Scale versus gauge, with a 16 mm scale binny tipper. The spring-loaded ashpan retaining pin. Broken up barbecue briquettes, for loco fuel. The first fire. The first great dump. New ashpan, to sprinkle ash between the rails rather than on the loco. Welsh steam coal grains, for the new ashpan.
Fire's nice and bright. Let's put some anthracite on. Look at that. Lovely stuff. Lovely stuff. Let's see what the loco makes of that. It's the sound of the blower. It's always going to pop and spit because this... Thank you. This blower line is external, so you get a lot of condensation. Look at that pressure, it's right up there. This anthracite is powerful stuff.
Smoke in the garden. The end. Thank you for watching.